everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about the surface area of solids, all those solid shapes like cubes, prisms, cones, spheres, pyramids, all of them. Since we are covering all of them here, I'm going to put lots of links down below so you can jump forward if there's a particular solid you are needing the surface area for. When we're talking surface area, we want to think of it like wrapping a present. So if I had a box that was a perfect cube and I wanted to wrap this, how much wrapping paper would I need? That's the question we're answering. Not how much stuff would go in it, how much wrapping paper would cover it. And in some of these more complicated solids or shapes, it can be helpful to think of if it was a box, opening that box up and laying it flat. What would it look like? So in the case of a cube, this is what it would look like. If I completely opened it up and flattened that box to take it to the recycling center, this is what it would look like. And so in this case, and pretend these are all squares, it would be 6 equal squares. And just a word of warning, when we're going into these, your math book may differ in what it says is the formula for surface area of a particular solid. There's variety out there in how it's presented, but the concept is going to be the same across the board. We're wanting to find all these individual pieces of this solid and then finding the overall area. So here again, to finish up our cube, we have 6 squares, 6 identical squares. So in this case, let's say it was 5 inches on each length, width, and height. Each of these little squares is going to be a 5 by 5 square. So I would find the area of one of these squares, and to find the area of a square, it's side times side, 5 times 5. So that would be 25. And then there's 6 of them. So 25 times 6, which would be 150. And I said this was inches, so our final answer would be 150 inches squared. So again, for a cube, find the area of one side, then multiply by 6. Moving on to rectangular prisms, our next level up in the difficulty challenge. Rectangular prisms are going to have 3 pairs of matching sides. Opposite sides in a rectangular prism are going to be the same. So the top and the bottom, those are going to be the same. The 2 ends are going to be the same. The front and then the back are going to be the same. So you have to find the areas of those 3 bits, multiply each one by 2, since we have 2 of each of them, and then add them all together. So let's say if this one I had as 5 times 3 times 4, 5 by 3 by 4. So what pieces do I have? Well, I have my front and back piece. That piece is going to be 5 by 4. So I'm going to write that down, 5 by 4, and I have 2 of them. What about my end pieces? Those are going to be 3 by 4. 3 by 4, and I have 2 of them. Then I have my bottom and my top piece. Those are going to be 5 by 3. 5 by 3, and I have 2 of them. Then once you have all those, you need to multiply and then add them all together. 5 times 4 times 2 is 40. 3 times 4 times 2 is 24. And 5 times 3 times 2 is 30 for a grand total of 94. And I didn't give units, let's say centimeters. 94 centimeters squared. So again, all of these, we're taking the pieces apart, keeping track of everything, and then adding them all up together. In our prisms, we also have things like triangular prisms and cylinders, which are also another type of prism. Now, cylinders are a unique little thing in itself, so we're going to save those for a minute. Any of those other ones that are like triangular prisms, or even you could have anything. You could have a hexagonal prism. You can have any prism, just the bottom and top faces are going to be identical, and then you have these vertical sides. In any of these cases, you're going to again take it apart piece by piece. You're going to, for a prism, find what the top and bottom are. They're going to match, so you just find the area of one of them and then multiply by 2. And then you have to break down all of the other sides. Here's an example, and we're going to keep it sort of straightforward here and say this is a right angle triangle. And I'm going to say this is that's 3, that's 4, and then the height here is going to be 10. Now what I did here, this is something just to be aware of. Sometimes they're going to, when triangles are involved, they like to be like, oh, we're going to be tricky, and you have to figure out what the other side is. That's going to happen. Refer to your Pythagorean theorem for that. Links will be below for relevant videos if you're needing review on that. Just be warned, they like to do that. So once you use Pythagorean theorem here, you're going to know that the other side of this triangle, which I'm going to write up here to make it a little clearer, keep it nice and neat, is 5. So 3, 4, 5, right triangle, and the prism has a height of 10. Now, depending on how you like to visualize things, it may be helpful to draw this like as if you were unfolding it. So like if I took this piece and lifted it up and flattened this all out, and I took this piece and rotated it down, what would this look like? So I'd take that top piece and it's going to be connected to this bit, and then on the bottom, you have that bottom piece. Then we have my other 2 pieces. If I were to flatten this prism out, that's what it's going to look like. And what are my measurements here? I have 3, 4, that's 5, 3, 5, and I know these sides are all 10 all the way along here. And what about these bits right here? Well, this one would connect to this side right there. They match up. So I know this is also 3. And this side is going to be touching that side. I know I didn't draw it to scale. So this side is 5. This sort of visualization can be tricky for students to go from 3-dimensional to 2-dimensional shape, but if you can do it, it is going to help you with these surface area problems so much if you can get used to doing this, kind of flattening it out and seeing what pieces are there. If you can visualize all that while it's still in that 3-dimensional shape and you don't have to draw it, that's great. Not everyone can do that. If you can, that's cool. If not, personally, I like to draw things flat. It helps me. So then we would take each piece apart, and this is part of why knowing all of your formulas for all the normal 2-dimensional shapes is critical and crucial for this, because here we have rectangles and we have triangles. So here's my first rectangle. That is a 3 by 10 rectangle. I have 3 by 10. There's my first one. Let me zoom out a little bit. I'll write it over here instead. I have 3 by 10. That's the first one. Actually, I'm going to leave that colored in since I've written it down. Then my middle one here is a 4 by 10. Color that one in as I've written it down. And my last one here, my last rectangle, is going to be a 5 by 10. And that's right there. Written it down. Now for the triangles on top, area of a triangle is 1/2 base times height. So 1/2 times 3 times 4. And I have 2 of these triangles. So to add these 2 into the mix, times 2. Now I need to do all this multiplication and add them together to get my total. 3 times 10 is 30, 4 times 10 is 40, 5 times 10 is 50. 1/2 times 3 times 4 times 2 is 12. So a grand total of 132. And I forgot to give units again, shame on me. Let's say inches squared. So that process of figuring out what the top and bottom are and then figuring out the sides is going to be the same for all of your prisms regardless of the top or the bottom. Cylinders, I mentioned, are their own little kind of unique thing. And this is where visualization really comes in handy. Let's see if I had a cardboard tube, like a paper towel roll at the middle. If I took scissors and I took those scissors and I cut, what would happen if I laid it flat? Would I have a circle? No, I would have a rectangle. If I cut that tube and laid it flat, I would have a rectangle. And this rectangle wraps all the way around into a circle. So that idea is going to be critical when you're finding the surface area of a cylinder. So if I were to draw a cylinder that had been flattened out, it would look like this. I'd have a rectangle or a square, depending on what I'm doing, and 2 circles. attached to it. I would need to find the area of each of those circles, and then I need to find the area of that rectangle. It's generally going to be a rectangle in the middle. So let's say the cylinder that I started out with, I'm told that the radius is 4 centimeters and the height is 10. Okay, so if I'm drawing on my little flattened shape over here, I know that the height is 10. Well, how long is this bit? I need the other side of that rectangle. That side, because it wraps around this circle, it's going to be the same as the circumference of that top circle. Formula for circumference is 2 pi r. I know my radius is 4, so 2 times pi times the radius 4 would be 8 pi. So this side down here is 8 pi centimeters. So I know this area, 10 times 8 pi, the area of this in the middle is 80 pi centimeters squared. Now I need to know the area of my two circles. The area of a circle is pi r squared. My radius is 4, so the area of this top circle is 16 pi, and the same goes for the bottom. And now I need to add all those up. 80 pi plus 16 pi plus 16 pi, talking faster than I can write here, is 112 pi. And that's going to be in centimeters squared. If it says leave in terms of pi, that's how you're going to leave it. If it wants a decimal, use your calculator to get an approximate for that. Next, we go to spheres. Spheres are their own unique thing in that we don't really flatten it. This is just one you need to memorize. The surface area of a sphere is equal to 4 pi r squared. Recognize that pi r squared is the area of a circle. You're correct. So what this is saying is that any sphere, let's say this sphere has say if we gave it a radius of 6 inches, this means is if I took a circle, a flat circle, a piece of paper that has radius of 6 inches, and I did 4 of them, those 4 circles, you cut them up into little pieces to make it all fit, would perfectly cover this sphere. Maybe hard to believe, but it is true, and that's one you just have to memorize. There isn't really like a way to break it down or figure it out if you forget on test day. You just have to memorize it. Surface area is 4 times pi r squared. So in this case right here, if our radius is 6 inches, 6 squared, fill that in, 4 times pi times 6 squared is 36. 36 times 4 is 144 pi. It'll be inches squared. On to pyramids. Pyramids are very similar in cylinders and prisms in that we are just taking the pieces apart and visualizing what they're going to look like. Flat is going to be very, very helpful. So this is a square pyramid. It's going to be a square if we were to flatten it out, and it's going to have this little triangle, poorly drawn, coming off of each side. Then you're going to fill in the information that they've given you. Be careful with this. Be very, very careful with this. A lot of times they like to give you this edge or any one of these edges. That's not going to be the height of any of these triangles because you're talking about it would correspond to these outside edges. And the height of a triangle, which you will need to find the area of a triangle, 1/2 base times height, is going to be that right there. That's going to be your height. So on terms of this pyramid, it would be like this, like the slant height on that pyramid. So be very careful for that. If they give you this edge, Pythagorean theorem is coming into play yet again. And what they are wanting you to do, let me get rid of these so it's a little cleaner. What they're wanting you to do is to calculate what that height is using the Pythagorean theorem. In most cases, they will give you this whole side. Let's say that is 6. They expect you to know, oh, when this comes down, it's going to divide this into 2. If I divide that to 2, that means this little piece right here would be 3. And then you have a triangle that has a right angle, and they want you to use Pythagorean theorem to figure out this other side. I can pretty much guarantee that's going to happen at some point. Just All math books love that. So same kind of thing with this one. You're going to find all of your measurements so that you can get the area of that base square and then those 4 individual triangles and add them together. So for this case, let's say if I had my base, say, is a square pyramid, 5 by 5, and then they're being nice and they give me that this slant height is 10. Then, all right, I have 5 by 5, and this height is 10, and this is a square pyramid. All these are going to match. They're going to be 4 identical triangles. So if I am figuring this out, I have 5 by 5 for my base square there. 5 times 5 covers that. And then I have 4 triangles with a base of 5 and a height of 10. Area of a triangle is 1/2 times base times the height. And then remember, I have 4 of these triangles. So 5 times 5 would be 25. 1/2 times 5 times 10 times 4 would be 100 for a grand total of 125. I can't remember to give you units to save my life, apparently. I'm going to say centimeters. 125 centimeters squared would be the surface area of this pyramid. The biggest thing to be careful of with the pyramids is to make sure that you know whether the bottom is a square, a rectangle, a hexagon, what have you, and do that accordingly. Make sure that the number of sides you have matches if you're multiplying multiple times, and make sure you're finding the area of that base correctly. If this is a pyramid that is not a square base, if it has a rectangular base, be careful with that because that means you're having 2 sets of different triangles. The ones on those 2 sides would be the same, and the ones on the front and back here would be the same. So just be careful with those for the pyramids. All right, we're in the home stretch. Last but certainly not least, the cone. Yay, last one. Right, so the cone, if I were to flatten this out, it would look a little funny. It would look something like that. And this shape over here on the left, which anytime you have what's going around the sides there is called the lateral area. So when I'm finding the area of this lateral area, it's like a sector of a circle. Erase this cone here to get out of the way for a second. A sector of a circle. Now, often in algebra, you find the area of a sector using the angle, what the angle is. There's another way of doing it, and that's what we're going to use for this one. It is 1/2 in a normal circle times the radius of the circle times the arc length. Now, I don't want to use this exact formula here because if I'm saying radius, it's going to get confusing because this is the radius we're talking about for this. Like, how do I represent this, which in a normal circle would be the radius? Well, in a cone, that's length right there is not the radius. It's what we call the slant length. Okay? The slant length. So that's transferring over here, the slant length. So again, in the original one, it's 1/2 times the radius times the arc length. Well, we are going to replace this R and say that is the L, the slant length. Well, now what is this arc length? What is it equal to? Well, it is going to wrap all the way around this circle. So it is equal to circumference of that circle, which is 2 pi r. So I'm going to replace this arc length with 2 pi r. Well, my 1/2, when I multiply by 2, that cancels out because 1/2 times 2 is 1. So the area is going to be pi times the radius of that bottom circle times the slant length of the cone. That's where that's coming from. So that's the area, this lateral area of this piece. We need to add that piece. Well, it's just a plain circle. And area of a circle is, we all know, pi r squared, right? So the surface area of this is going to be pi r squared plus pi times the radius times the slant length. I said this at the beginning, I'm saying it again. Different math books, different sites and things are going to present these formulas slightly differently, but the same principles, the way you're piecing it together, it's going to be the same regardless. So let's say I was given a cone and I was told this cone had a radius of 4. It has a slant length of 10. Then, to use my formula, the bottom there, pi r squared, pi times my radius squared, plus pi times the radius times the slant length. Pi times 4 squared is 16 pi. Pi times 4 times 10 is 40 pi. Together is 56 pi. You should know by now I always forget to put on units. So 56 pi, and I'm going to call that feet squared. It is apparently a massive cone, a cone of truly epic proportions. So that's it. Those are the surface areas of all your major solids. Congratulations on making it to the end, and happy surface area finding. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.